Hello everyone. Today we'll be discussing a very common technical interview question which you may expect in the very initial rounds. So the question goes like this, that you have been given an array which represents the value of stocks in respective days. So let's say you have been given an array like this. So the value at the 0th day, on the 0th day is rupees 100, and then on the first day is 180, and so on, right? So the question goes like this, that we need to find the maximum profit that we can earn by buying and selling the stocks on multiple instances, right? So when we say buying and selling, so it goes like this, that for this example, you can buy the stock on day 0 and then sell the same stock on day 3. So this is where the first transaction gets completed, and then again buy a stock on day 4 and then sell on day 6, right? So we can say that one transaction is buying and selling the stock, right? And there are other constraints as well in this question, and it will make sense when we start implementing the solution. So the constraints are like, you cannot sell the stock on the same day of buying it, right? It makes more sense, because since we anyways have to calculate the profit, and if we are buying a stock, let's say at value X, and we are selling the same stock at value X on the same day, so the profit earned is 0, right? So also, to make this question a little easier, and to check what your approach might be, an interviewer might also give you an easier version of this problem, and he might ask you that you have to find the maximum profit, but you are just asked to buy and sell the stock only once, right? So in this example, if you are asked to buy and sell the stock only once, it turns out that you will be buying stock on day 4th, that is at rupees 40, and then selling the same stock on day 6th, that is on 695 rupees, right? So your total profit earned would be around 655, right? So we'll first try and implement the scenario wherein we are asked to buy and sell the stock only once. So let's start. So we'll see what we can do. So the idea here is to find the max difference in linear time. So let's say we store minimum as the current element, which is array of 0 for now, and then we can have something like max if as it is means of start. In languages like Java, you can have integer dot minint, or I guess min, and with C++ you can have min int, right? So with Python, it's just this way. So we are just storing the minimum possible integer value in maxdef for now, and then we for x in range 1. So it will be traversing the array from day 1st, and anyways, since we have stored the minimum, assuming that at day 0 it is the minimum, right? So we'll have n, which is the length of the array, right? So if the current element, which is array of x, right, is less than the minimum, so we can assign minimum to that current element, right? And also at the same time, we'll check if max diff is less than array of x minus minimum. We'll have max diff is equals to array of x minus minimum, right? And then we can just return the max diff. So, well, how does it? How do we proceed with this? So we have the minimum set as array of 0, which is 100 as of now, and then the max difference is as of now is 80, and then it is 2 260 minus 100 160, and then 210, and then we hit this 40, so we'll have minimum as 40, and then max difference will be 535 minus 40, which is more than 210, and then we'll have 695 minus 40, which is again more than 495, right? So we should get 695 minus 40, which is 655, right? So we'll check. Yeah. So this is the easier version of the question wherein you are just asked to buy and sell stock only once, and the more uh, common question that you might expect is when you are given the values of stocks and you are allowed to buy and sell the stocks multiple number of instances. So this question turns out that you need to find or figure out the local minima and the maxima, and then uh, selling and buying and selling on respective local minimas and maximas, right? So we'll as I've just discussed earlier, so the transaction is one complete transaction is buying and selling the stock, right? So as of now, let's say the total transactions made as 0. So we'll have something like while I is less than n minus 1, right? So we need to find the local minima, right? Why I'm saying this, let's take this example itself. So if we take this example, let's say make this 90. So the local minima here is 90, lesser than 100, right? So we can assume if we buy the stocks at rupees 90, we can expect to get profit afterwards. We can just expect. We are not sure, but we can expect, right? So we can have something like while I is less than n minus 1. Why n minus 1? Because we will not be able to buy the stocks on the last day, right? Because we can't sell the stock on the same day. That is one of the constraints in the question. And and so we'll have prices of, so I plus 1 is less than equal to prices of, right? So it goes like this. So you are at 100 and prices of I plus 1, which is 90, is less than this. So what we'll do is like we'll increment I. We'll say the possibility of buying a stock on a day later than the current day is will give us more profit with increased probability of the same, right? So once we keep on doing this, we need to store that transaction, right? So we can have something like, let's say, we will have a class, let's say interval now, and we can have, mm, let's say, self dot buy. It will store the day in which on which we buy the stocks, and sell will store the day in which we'll sell the stock, right? So you have something like this. So we can have, we will be buying on ith day, right? Okay. And then there is this constraint that we cannot sell the stock on the same day. So we can increment the I because we cannot sell the stock on the same day. And then we need to find local maxima, right? So we can have something like while I is less than n, and prices of current element, okay, is will be, it should be right. In this case, it should be just greater than the previous limit, right? So we can have I minus 1 less than equal to prices of I, right? In that case as well, we can increment, and then we can sell the stock on that particular day, right? To hold the complete transaction, we also need something like list. In Java, you can have array list of intervals, right? So this, okay, and then we can store, right, solution dot, and this interval we can append, right? And then one transaction is complete. So now all we need to do is, I guess, print uh, the days in which we'll be buying the stock and selling the stock. So buy stock day. So we'll have something like solution of buy day. This looks fine to me. Then we will be sell stocks on day. Okay. Sounds correct. Seems correct. Yeah. Let's check. So what we are doing. So we are trying to find the local minima. In this case, we see that 90 is the local minima as of now, and we will try and buy the stock on the first day. Okay, and then we'll store the day on which we bought the stocks in an interval, which will add to the number of transactions, uh, which will add to the solution set. Sorry, and then we try and find the local maxima. So in this case, we'll store the day on which we'll sell the stocks, and then we'll finally append our interval wherein which we bought and sold the stocks to the solution set, and then we'll increase the total number of transactions that are completed. So one transaction is buying and then selling the stock, right? So I guess that should work. And with this example, we should get buying stock, buy the stocks on day 0, and then sell the stocks on day 3rd, and then buy on 4th, and then sell on 6th. Let's see. Okay, I got some issue on line 69, right? Okay, I missed the N operator. Now let's see. Okay, so we are buying stock on day 1, selling stock on day 3, buying stock on day 4, and selling stock on day 6. So why? Okay, yeah. So we buy stock on day 1, which is 90. Then we sell the stock on day 3rd, and then we again bought the stock on day uh, 4th, and then we again sold the stock on day 6th. Right. So I hope you did understand the solution which I shared with you. And if you have any questions or queries, uh, please leave the comments.